This is a quick review of how to find average velocity. I'd like you to imagine a simple scenario first to help anchor our understanding. Let's start with this scenario. Suppose you're on a road trip, and for 1 hour, the car is moving at a constant velocity of 60 miles per hour. And then you hit traffic, and you spend the next 7 hours sitting in traffic, moving along at 30 miles per hour. I think pretty intuitively here, most of us will recognize that the 7 hours at this low speed is going to influence the average velocity. So the average of 60 and 30 comes out to be 45 miles per hour. That doesn't take into account these times. So the actual average taking into account these times is going to come out somewhere closer to 30 miles per hour. So let's think about how we might set up that calculation. The total trip is 8 hours long. And we're looking to find this average velocity for that time. So 8 hours is the total trip time. 1/8 of the time we're driving at 60 miles per hour. And 7/8 of the time we're driving at 30 miles per hour. This will appropriately weight your average for 1/8 and 7/8. Let's see what we come up with. I'm going to grab a calculator and we'll be right back. Because of course, who shows up to their own video with a calculator in hand? Okay, so when I do that math, I get a little over 33, almost 34 miles per hour. So we're going to see an average velocity of nearly 34 miles per hour. And that fits with our gut feeling initially that the average, because of how long we spend going at this slower speed, it's going to tend towards the 30 miles per hour. So this is one way to calculate an average velocity. Let's look at another approach based on a position time graph. So for the first hour, we'll just estimate here, this is 1 hour. Here's 8 hours. So for the first hour, we're going to travel along with a velocity of 60 miles per hour. We're going to cover a lot of ground in that time. In fact, 1 hour times 60 miles per hour, we're going to travel for a distance or a displacement of 60 miles. So I'll just estimate that in here. Let's see how this works out. We're just going to call that 60 miles. Okay, now 7 hours traveling at 30 miles per hour. 7 hours times 30 miles per hour. We're going to travel 210 miles. I can tell that that's going to travel way off my graph, so let me back up here and make this line a little less steep. I'll start here. We'll call that 60 miles. This probably won't come out to scale. I'm just going to kind of freehand it here. In the next 7 hours, I need to travel forward 210 miles. I want this to happen at a slower speed, so I need a shallower slope. This should look like a point of inflection here, a little point where we're going to get the line a little shallower. There we go. That visibly looks like a change in slope. So this, from this point to this point, 210 miles. if I wanted to add that to the initial 60 miles, this will wind us up at 270 miles. So to be clear, I'm traveling forward 60 miles in the first hour, 60 miles in the first hour, and in the next 7 hours, I'll travel another 210 miles. So this is 210 miles after 60, you get to 270 miles. This total trip is 270 miles long. Okay, so I said there's an easier way to get at this average here. Let's look at how to do that. If I take the total displacement and divide by the total time, that's the equivalent of connecting this line. The total displacement, 270 miles, the total time, 8 hours. So velocity average can be found by taking total displacement over total time over total time, that's 8 hours. 270 divided by 8 comes out to be 33.75, just like we got previously. So 2 ways that you can find average velocity. One is total displacement over total time. Let's put a big box around that. That is a super big idea. The other method is by figuring out the fraction of time traveled at each different velocity. Hope that's been helpful. Review of average velocity.